Have you ever stopped to think about what actually holds our digital world together? You know, from the apps on your phone to every website you visit, there's this invisible blueprint, an organizing principle that keeps it all from just falling into chaos. Today, we're going to pull back that curtain and explore these blueprints. They're called software architecture styles.
But first, let's just think about the alternative for a second. What happens when there is no blueprint? When developers just start building, without any real high-level plan for how all the pieces are supposed to fit together?
Well, you end up with what our source material just so perfectly describes as a duct tape and baling wire spaghetti code jungle. It paints such a vivid picture, doesn't it? A messy, tangled system that's just held together by quick fixes, where it feels like every single wire is crossing every other one.
Now, in the software world, this actually has a formal name, the big ball of mud. And it's what we call an anti-pattern. That means it's the exact opposite of what you want to create. It's pretty much what happens when a system just evolves, with no deliberate design at all.
And what's really interesting here is how these signs all feed into each other. You see, a small, simple application starts off with this unregulated growth. Then, as problems pop up, developers just slap on these hasty repairs. That's your duct tape and baling wire. And because the structure was never clearly defined in the first place, every one of those fixes just makes the system more and more tangled, which then makes the next change even harder. It's this vicious cycle that architects are trying to avoid at all costs.
So if that chaos is the problem, then what's the solution? How do we build systems that are actually organized, manageable, and, built to last? Well, the answer isn't to code harder, it's to plan smarter. It all comes down to having a blueprint for your code right from the get-go.
And that blueprint is what we call an architecture style. It's not about the nitty-gritty lines of code. Nope, it's all about the big picture. It defines the major parts of the system, like the user interface you actually see, the backend code that's doing all the heavy lifting, and the database where all the information is stored. And it sets the rules for how they all talk to each other.
And this just shows the difference so clearly. Instead of unplanned growth, you get deliberate design. Instead of a system that's an absolute nightmare to change, you get manageable evolution. And that's huge. It means you can update one part of it, say swap out the database, without having to rewrite the entire application. You also get improved testability. Why? Well, because with a clear separation, you can test each component on its own, making it way easier to find and fix bugs. You're basically moving from unpredictable chaos to defined, understood characteristics.
Now, here's the crucial point. There is no single best architecture style. Think of them like different kinds of vehicles. You wouldn't use a sports car to haul furniture, right? And you wouldn't use a moving truck to compete in a road race. Each style has its own strengths and weaknesses, its own set of trade-offs. An architect's job is really to choose the right style for the specific problem they're trying to solve.
So where did these styles even come from? I mean, they didn't just appear out of thin air. They've evolved over decades, really driven by changes in technology and the growing complexity of software itself. So let's trace that evolution and see how we learned to split the system up into more manageable pieces.
In the super early days of computing, the software and the hardware were pretty much one single thing, a unitary architecture. But as technology got more advanced, this powerful idea started to emerge. What if we split the system into distinct parts? And that idea led to the two-tier architectures of the 80s and then the three-tier architectures of the 90s. At the very heart of this evolution is one of the most fundamental patterns in all of software, the client/server relationship. It's such a simple but powerful concept. The client asks for something, could be data, a calculation, a web page, and the server provides it. This separation is the key to almost every single style that came after it.
The first major split really happened in the 1980s with the rise of personal computers. All of a sudden, you can have a desktop application, that's the client, handling everything the user sees and interacts with. It would then connect over a network to a big, powerful, standalone database, the server, which handled all the data storage. And that was the two-tier architecture.
But then came a technology that would change absolutely everything. The World Wide Web. The simple two-tier model just wasn't quite enough to handle the demands of this new connected world. And that led to the next big evolutionary step.
You see, the web introduced a brand new kind of client, the web browser. But it also brought in a new middleman. You couldn't just have millions of browsers connecting directly to your critical database, no way. You needed another layer in between to handle all the core business logic, the security, and all those requests at a massive scale.
And that gave us the classic three-tier architecture that dominated the 1990s.
You've got the front end, which is what you see in your browser. Then there's the application tier sitting on a web server holding all the business logic. And finally, the database tier, an industrial-strength system storing all the data. This separation became the go-to style for years, and for a good reason. It allowed specialized teams, front-end devs, back-end engineers, database admins, to all work on their parts at the same time, which drastically sped up development.
Okay, so we've gone from total chaos to this layered structure, from a single unit to distinct tiers. But this isn't just some academic exercise. Having a name for these structures, like 3-tier, has a really profound impact on how we build software. So let's talk about why that shared language, the power of a name, is so incredibly important.
This, right here, is the core takeaway. When one architect says to another, hey, we're building this using a 3-tier architecture, that single phrase communicates a massive amount of information. It instantly defines the major components, their responsibilities, and how they're all going to interact, without needing some 10-page document to explain it. It's just an incredibly efficient way to communicate.
As our source material puts it, each name is just packed with understood detail. It's a shared vocabulary, a design pattern that lets teams get on the same page instantly. And that shared understanding is what allows us to build these incredibly complex systems collaboratively and, effectively.
But the evolution from a single unit to 2 tiers to 3, it hasn't stopped. The complexity of our digital world just continues to grow, exponentially. And this leads to a final question. As we build even more sophisticated systems, what new blueprints, what new architecture styles will we need to invent to manage all that complexity and keep building the future?